Yeah. I guess you see my screen now. I'll present.
I see it, yes.
Let me just. Okay, so hi everybody. I'm just trying to second. Okay. So thanks, Ken, for bringing us here. I ended up putting a broader talk than I imagined, where the common theme is, put it as kind of moving out of the comfort zones, and where we might take benchmarking. But I think my approach is more of like a bottom-up one. I mean, the points I plan to bring up are more bottom-up kind of perspectives, where I was addressing, again, like Dave, I was suggesting that the kind of things we are doing today, you know, maybe we managed to address many applied settings, but there's still many more things for which our technology is impractical, and to a large extent, you know, I would identify with what Dave said. But I think there's more we can do even before we manage to do the kind of eventual goals Dave is aiming at. So from that perspective, I was thinking of contributing to the discussion 3 directions for NLP benchmarking. All of them are kind of pushing us out of certain comfort zones in certain directions that I think can take us forward from where we are now. Maybe not in one step reaching where we want to be, but at least making substantial steps further. And I split that to 3 directions. The first is methodological, and it's more about the how to do benchmarking. So from that perspective, it's kind of related to Sam's talk on some principles on the methodology of benchmarking. But I kind of boil it down to a single principle that I think can be a guiding principle. And I've prepared some use cases for that. I've illustrated some use cases for that. While the other 2 are more not about on the how to benchmark like the first one, but around what to benchmark, where one of them is on what to benchmark in expanding our application scope, and the other is how can we revisit or extend NLP, modeling of NLP infrastructure. So let me just go one by one. So first about the how. And here, the perspective I suggested is thinking of realistic scenarios, which I'll explain right now. When I'm saying realistic scenarios or versus comfort zones is simple, right? I mean, it seems that some of the benchmarks we are using them because they are easy to construct, in a sense, often easier to model. People claim that we are doing data sets rather than tasks. But what would realistic be? And the kind of simple guiding principle I'm proposing for realistic is that models, that when you develop a benchmark, I mean, eventually we're developing benchmarks so that people will develop models to be tested over these, to be trained and tested over these benchmarks, or at least to be, to address these benchmarks. And I think the guiding principle for realistic should be that once you design your benchmark, try to figure out how, I mean, the best you can, how models that would be evaluated on your benchmark or trained on your benchmark would be used downstream. And then try to design your benchmark from both perspectives of data composition as well as evaluation protocols, such that these would simulate as much as possible the downstream use of models evaluated on your benchmark. That's the key point I'm kind of communicating in that part. And I'm illustrating that with 3 use cases, which I'll go through very quickly. I just hinted them, and you're welcome to look at the talk. The first is about few-shot relation classification. Few-shot is a very attractive setting. And however, when we worked on that task, we noticed that the main data set for which over which few-shot relation classification is tested, has various kind of drawbacks. And I won't go one by one, but most prominently they are related to relation distribution. Just have in some sense, a wrong relation distribution. On the other hand, some classical relation classification datasets for supervised setting, like TACRED, do have a proper distribution of relations or data composition in them, kind of much more appropriate sampling of the data. And here we made a contribution in suggesting a general procedure how to transform the easier type of data sets for supervised setting to few-shot settings. We propose certain procedure for that. And when we do that, we see that we indeed get a much more realistic distribution. And also we see that when you confront realistic distributions, things become much harder. This is the performance of a state-of-the-art model on the kind of the classical or earlier data set for few-shot relation classification. And this is the performance of such a model on this few-shot TACRED on the much more realistic. So we see here that actually doing things properly, simulating reality properly, in a sense reveals that models aren't good enough. And this was about improper data composition. In another work on cross-document co-reference, we noticed that the evaluation protocol is not realistic. The data is fine, but the evaluation protocol doesn't properly simulate the downstream use of co-reference resolution. And we identified several deficiencies. Again, I won't go one by one. And these deficiencies, I'll give an example with the Singleton Effect, which you're welcome to look at the talk to understand what it is. But basically, if you are considering singletons in your evaluation, as people did recently, you end up preferring a system S1, which in some sense, from downstream use perspective, is less effective than the other systems, than S2, if you evaluate the way people were evaluating in recent years. But if you change that protocol to ignore singletons, suddenly you surface the more effective system, the more useful system to have better scores. And more than that, you see that if you take the combination of all realistic aspects needed that would simulate downstream use in the evaluation protocol, performance decreases drastically, in fact, by 32%, 32 F1 points, again showing that actually current technology isn't good enough. And then the last kind of data composition we discussed is textual entailment. I refer to that because at my group, we kind of initiated the textual entailment as an empirical task. And the point here about proper or realistic data composition is that, in fact, the underlying motivation for textual entailment is because it captures semantic inferences in many downstream tasks, which can be reduced to entailment recognition. So the beauty of textual entailment, that it's not a task on its own, but rather you can take out certain key inference tasks in many other settings, in many other applications, and reduce them to entailment. And therefore, when we designed the earlier textual entailment datasets, we derived them from datasets of other applications, which we transformed properly by this kind of reduction into entailment instances. And that gave us kind of more realistic data for to reflect downstream use, as well as natural premises and hypotheses. The most popular datasets for later textual entailment was termed NLI, natural language inference. These datasets were composed in a more synthetic way, again, not getting into the details, which makes it less clear in what sense they are realistic or simulate downstream use. And my proposal here is again to revisit this direction. And I think there's great opportunities today with modern data sets for a range of inference-based applications to derive new textual entailment or NLI data sets from these. So taking all these together from the methodological part, I think the key point here is to consider how the models evaluated in your benchmark will be applied downstream and try to design your benchmark to simulate that. So that's about the how. And now I also propose two directions about the what at two different levels, one at the application level and the other at the infrastructure level. So with application, a main direction I'm proposing to advance through proper benchmarking is interactive applications. NLP benchmarks are offline. There's huge potential for interactive NLP, but today only dialogue systems is the only kind of substantial interactive field in NLP in which the setting is interactive. And I think many more applications can be transformed that way. We did some work on interactive summarization. Here is some demo I'm showing for interactive setting, but the key point is, and there were prior systems, but the key point, I'm skipping these, is that in order to enable research on interactive applications, we must devise proper ways to evaluation protocols for interactive systems. And here we propose something that views an interactive session as a sequence of snapshots, each of them actually static. And that allows us to apply some aggregation of measures for static summarization, like these recall curves and area under curves. So kind of individual points become a curve in the interactive setting that models the session and evaluates the session. And we see that this allows to incorporate both automatic measures, manual measures, and doing proper session collection, and eventually allow to evaluate interactive settings similarly to how we evaluate static settings. And finally, I'm also proposing to extend benchmarking or to revisit benchmarking of infrastructure tasks. I mean, in recent years, when things become end-to-end, we care less about evaluating intermediate structures, but I think it's time to revisit those. I think there's evidence that just end-to-end systems isn't enough. Many people try to use intermediate structures, example from last knuckle, using some open knowledge graphs. And what I'm proposing here, that rather than getting back to things like AMR or other kind of structure formalism, an appealing direction is to look for semi-structured natural language-based representations like USRL, where you just take a sentence where the semantic analysis is simply decomposition to a set of natural language questions. So the semantic representation by itself becomes a somewhat more structured, semi-structured, natural language-based elements. And these elements, which we extend to cover a broad range, these elements, I'm skipping those, these elements now that are natural language-based, the beauty is that they are now amenable for the kind of modeling we do on the raw text with language model-based embeddings. Now these can be done over our own representations. Still, we get something that's more explicit and can give us back the power of intermediate representation that seems to be missing. So these are three directions I was proposing methodologically at the application level, at the infrastructure level. And I think these are three steps out of many more that can take us some way forward.
Okay. So Ido, I was wondering if you could help people who may not know the history of the field that well, and that you mentioned entailment. You mentioned that your group had done some work on entailment. I don't think you explained how entailment is used in the glue benchmark. And I kind of see a connection between what you're talking about here and that older work, in that what you did in the older work was to try to push the community to work on some harder problems than what we used to be working on at that time. And I think now you're doing it again. Is that a fair description of this? And then and in any case, could you explain what you did the last time?
Yeah, that touches on kind of the entailment aspect. I guess maybe that's my kind of...
Yeah, so what did you do with entailment? Where was the community before and after you did that? And how is entailment used in glue?
Yeah. So before, you know, and Sam may help me if I miss some points. I think he's also familiar with this space, even though he joined somewhat later. So before we introduce entailment as as an empirical task, textual entailment as an empirical task, most work that dealt with semantic inference, generic semantic inference, was closely tied to logical representations or some other formal representations. So it was typically assuming certain theories of representation in order to model inference as a generic task. On the other hand, of course, we had the concrete tasks like information extraction, question answering, and others that were approached more empirically. But these didn't have any more generic infrastructure to use, because some people develop QA systems with logical formalisms, but that was the exception. I think the innovation was in what we proposed is framing textual entailment as kind of a theory-neutral task, an empirical task with text in, text out, over which you can apply any type of model you want. And the motivation for specifying particularly this task is indeed this reduction I mentioned. I mean, again, you need to look at that. I don't have time to go over that, but you can reduce like the inference of verifying that your question answering system response is correct through an entailment. You can represent it as an entailment inference. You can verify that your, let's say, relation extraction is correct through an entailment inference. There are ways to make these reductions. And I think that's what caught up. That's why, you know, now it's like 16 years later, and then, you know, with its current name, NLI, yeah, I have reservations about this name.
Well, once it's escaped, it's no longer yours.
Yeah,
right?
yeah, but anyhow, it's pretty much the same task. You know, I got my ACL fellow for that, so that's I'm done. I think that's the reason why it's there, and we see that that vision worked out. Right today, many people put entailment or NLI modules into many other systems in order to perform the inference steps they need, like in question answering or in, let's say, summarization, checking for factuality, and so on and so forth. So that's what I think what made it there. But I think something that got lost on the way is this desire to, in entailment datasets, to have entailment datasets simulate the kind of realistic inferences that the downstream tasks would use. And in the early datasets, which were much more naive, small scale back then, much lower budget also, that was the driving principle with more or less success. And I think now it's a good time to revisit that.
So I was wondering if this approach would address this earlier debate we had as to how to test what Dave wants to do. That is, if I could reduce it to a text in, text out. But I think Dave would probably be very unhappy with what happened to entailment after it left you, that people are now solving it with transformers that Dave would say don't understand anything.
Yeah.
And that we can do well on entailment without maybe understanding.
I think the last point, the last part I was making, you know, about getting back into some interpretable explicit representations, you know, the decomposed meaning, decomposed semantics, you know, might be a potential direction to go, in the sense that it tries to bring back kind of more interpretable representations, but maybe of a different flavor that's more suitable for today. And as you could see, these are also in a sense theory neutral, but they are, you know, more controllable and interpretable, not fully as classical logical representations, but on the other hand, with the power of kind of shallow technologies we have today, maybe I think they are worth trying.
Anybody want to respond? All right, I don't see any hands up. If I'm missing one, speak up now. All right. I think that's really great. And as usual, we're slipping on time. So maybe we should move to the next speaker, but thank you very much. This is really great stuff. And the talk, as you say, is really dense and chock full of a whole lot of content. So, you know, we only scratched the surface here. Yeah. So, at any rate, let's thank the speaker, and then maybe you can stop sharing. You already have. Sam, do you want to come up?
Sure. I was just finishing typing a reply to Ido.
I'm sorry. You had something.
No, of course. Yeah, just while I'm pulling up my slides, I completely agree that there is this weird mismatch. So I think what you were alluding to with me and with Adina, who's also on this call, is we put together 2 or 3 very, very big textual entailment data sets that have been popularly used for testing transformers. And they were, I think, inspired by the very abstract version of what Ido was describing of you can reduce lots of interesting semantic behaviors to this task. But they, unlike the RT data sets, unlike Ido's group's data sets, they weren't particularly meant to be tied to any applications. And they weren't really designed to even be indirectly probably useful for applications. So we went into this odd situation where I think the vision survived, but just because these data sets were quite big, a lot of the attention has moved over to these data sets that are actually not designed to be nearly as useful as the earlier smaller ones were. So I'd be very happy to see new data work that's a little bit more grounded in that way. All right, let me slides. All right, so I've taken plenty of time already. I'll try to be very, very quick. So my talk was, I think, complementary to at least parts of Ido's talk. I think there's a lot of debate at this workshop about what tasks and at what levels of granularity should we be benchmarking NLP systems. This talk is very much about sort of once we have the task in mind, once we've decided on exactly what we're looking for and exactly what kind of data we're looking for it on, how do we actually go from that specification to building a test set? And this is kind of trying to diagnose and pick on some issues we've seen with how this has been going in NLP recently, and very much picking on work that I've done in past years. So it was kind of based on this observation that comes up a lot, that we've gotten into the habit of building test sets that supposedly test something like text understanding in a general way. We beat those test sets, and then we find other independent evidence systems that beat those test sets aren't robust in the way that we'd expect them to be, given what they say they've accomplished, given what the benchmarks say they test. And so we're kind of trying to ask, what would it take to build benchmarks that don't do that? Where if a system does well in the benchmark, we actually should be satisfied that it works. So we sort of break down our diagnosis of where we're going wrong into 4 directions. Validity is just how well the data set corresponds to the task. This is really tricky. There aren't, I think, real silver bullets for how to guarantee a data set is valid. I think Ken has pointed out that this is, I think, somewhat analogous to the validity problem in psychological experiments. Reliability is this issue that just sort of cheap, noisy annotation processes introduce a lot of errors into test sets, and the particular kinds of errors we get can create sort of spurious signals that suggest a model is at superhuman performance when it isn't, and this is something we should be paying more attention to. Statistical power is sort of just what it says on the tin, and social bias, I think, is this point that hasn't this point that's a little bit separate from the main theme of the workshop, which is just that we can easily fall into this trap, and I think we have in the past of building benchmarks that say something like, hey, if you solve this benchmark, you have a good reading comprehension system. And we can wind up with a position where we build a benchmark that says that people outside in industry, especially in smaller companies, sort of take us at our word that, okay, this system does well at this benchmark, so it is a good reading comprehension system, obscuring the fact that likely the system was trained on sort of naturalistic data, and so is likely to have the kinds of biases that will show up in naturalistic data. And we have, I think, some obligation to at least signpost the sorts of ways that training kind of generic machine learning models and generic data can produce outcomes that look good, that pass difficult tests, but that are biased in ways that make them inappropriate for use in high stakes situations. Like, I don't know, picture, do you want a squad model to be involved in resume screening? We sketch out sort of all the things that we think are going wrong. I make this argument that this sort of Dynabench model and loop style data collection I think can offer sort of false hope here that it can give you data that looks challenging in the ways we want it to be challenging, but that doesn't actually correspond very well to the task we want, isn't actually valid, and is likely to be less valid than data collected under other similar means. This is a solution that's proposed that I think is pointing to some extent in a discouraging direction, and I think there's some evidence of ways that can go wrong. I also argue that you'll sometimes see few-shot learning experiments where a model isn't allowed to train on any significant amount of the kind of data that we tested on, proposed as a way to build sort of safer, more valid benchmarks. And I think that's true, but also that doesn't correspond to many of our real world problems. And so to stay grounded in the real world, we do have to solve the problems that I set out in sort of somewhat this more conventional way. Just get better at crowdsourcing, get better at data set design, get better at validity research. And then we sketch out a few ongoing research directions and a few recent results that I think are pointing in the right direction. I don't think I have time to recap all of those now, but thanks.
So when I'm reading the chat, it looks to me like most of the comments are on the previous discussion. Does anybody have something in the chat they want to bring up to Sam? Any hands raised anywhere? Yeah. So I keep harping, and Sam, I think, brought this up. There's an echo someplace. Anyway, so I kind of like to see lots of interdisciplinary work. I think it's really useful for us to bring together people from different fields. So like bringing in the systems work, I think is really useful. And I think we could benefit by having more of SIG-IR work, like what Ellen's going to represent, or more web search. And here I think the connections from what Sam's talking about to experimental psychology seem really deep. That is that I think Mark earlier on thought that maybe better than sort of psychology is more like education. The people there have thought a lot about exactly what am I trying to test? Am I trying to test that the school is any good, or that this student is worthy of a precious place in a very competitive university, or am I just trying to test whether or not the curriculum works for some very broad class of people? Who knows? But anyway, here a kind of question that was coming up earlier is, how are the machines comparing with people? And there's lots of people out there who are drawing all kinds of conclusions. From Dave's work with Jeopardy, I have a feeling he had to do a lot of walking back of why Jeopardy didn't actually solve, the Turing test, or why Jeopardy, that is. I heard some executives saying, based on Dave's work with Jeopardy, that we now have a machine that can answer all questions, including undecidable questions.
Well, anyway, now you know why I ultimately left.
Right. But the problem is, if we don't come up with a good answer to how to set reasonable expectations, we're all going to have to leave, right?
Well, I don't know. I think, after how many AI winters were there too? I thank God Jeopardy didn't quite close another one, but I think we're here to stay. I do think, there's an obligation to kind of try to raise the bar and to be more straight about what these things are capable and not capable of. But that's up to us as a community, decide. Yeah. I think we're at a point where there's so many potentially great applications of the technology that, we're here to stay in that sense. But what do we want to achieve? And anyway, the conversation that we keep kicking around here is it practical to do this, to test systems, to do sort of these more ambitious, goals that are harder to define and more subjective? And what that says to me is that, it involves more, at the very least, it involves more work. one point I wanted to make, and I could appreciate the criticism on some of the conversation that was happening earlier, is that, you know, we shouldn't get too philosophical, right? Get caught in this thing. I was like, let's all debate what understanding is and what it isn't. And I don't think that's the right takeaway. I think the idea is, are we willing to do, and I think, Ken, you mentioned it about, you know, hybrid. It's like, are we willing to just do more expensive tests and potentially are really looking into whether or not the answers and the explanations are satisfying humans, whether or not humans are becoming, making them more effective at the job. I mean, I run into customers all the time who say, I'm not going to use this stuff because I can't explain to my patient or my client why it's producing the answer it's producing. Not using it.
No, interpretability seems like, you know, a lot of people think it's sort of the way out of this mess. Now, John Massey, though, you had a different, you were describing a situation when you started where whetstone and drystone were the standards, and you didn't like those standards, and you came up with a better one, right? And I don't think it was easy. Maybe in retrospect, it looks easy, right?
And well, no, it wasn't easy. You know, as I noted, all of us in the industry who did performance documents always ended up quoting things like whetstone and drystone, which are little synthetic benchmarks that were easy to compile and everybody used, right? We all hated them. We all had realistic benchmarks that just different, right? Now, I went on a mission to try to kill off drystone forever. Right. We even got into spec Reinhold Weicker, who wrote the original version of drystone and who completely disavowed it. Okay? And drystone is still around some. So this is my comment before, is it's like I say, Gresham's law of benchmarks is that small, simple, bad benchmarks can drive out good ones, or at least it takes a lot of work to ever get rid of them. So it's a long, hard fight. I mean, it's getting good benchmarks and keeping them good by discarding ones that turn out not to be so good, and finding new ones is hard work. It takes a lot of effort.
Right.
Yeah, I would add, one of the experiences that I had in talking to other benchmark communities is that there's to riff off of what John was saying, is typically within the community of practitioners, there's an understanding that performance is a complex surface, right? But then I think when you get to Ken, as you alluded to, the executives that Dave was working at with Jeopardy, they're like, you know, we need one number, right? Or, you know, you talk to people in Congress, they're like, how do I measure how good my supercomputers are?
I need executive math, right?
Yeah, and that's one of the things, is like there's sort of fundamentally a drive for explainability to a broader world, and those folks are often, you know, because they're not experts, they need something that's simple. And I feel like that sort of projection of a complicated space down to something that's simple and you can do in like 20 seconds, right, that's where you have some of those losses, right?
So in Sam's list of things here, like, you know, validity and reliability and so on, I didn't see KISS.
Oh.
I'm not sure I quite got
KISS
the
is keep it simple, stupid. We need executive math. So
what does that
John,
mean
can you explain this, why you can only get one number?
Well,
what was that?
Sorry, was that for me or was that?
Yeah, John, that was you. You kept saying that all these executives want one number and only one number. And then maybe now you got two numbers or something at some point.
Well, so it actually, in the early spec days, we all of the practitioners who've been doing this for a while thought we needed two or maybe even three numbers. Okay, one integer number and one or two floating point numbers. Okay, the pushback came from sometimes from customers, but particularly from the folks like EE Times and some of the other magazines that basically told us keep it simple, okay, coming out the door. We want a replacement for MIPS ratings. You won't get rid of MIPS ratings in Drystone unless you just give us one number. So we sort of gritted our teeth, did one number, knowing perfectly well there were really at least two separate clusters. Right? I think that the fundamental tension here is that if sets of benchmarks are really fundamentally different, they shouldn't all be lumped together, right? You sort of want to keep the minimum number of clusters that you've got, right? But everything should be as simple as possible, but no simpler. And we very quickly went to two numbers for the CPUs. And again, one could argue that 3 is more like it, but I didn't want to go that far. So I don't think there's anything magic about one number. It's that people do want sort of a minimal number of things that they can relate to. Now, certainly computer architects sometimes like one overall number where they can do figure of merit, like do we get 1% overall on performance across this whole set of benchmarks to justify 1% more die space? I mean, I've been in sessions like that, okay, right? And people sort of don't want to say, and we'll look at that for every one of 20 benchmarks. They just sort of don't do that. So I think there's a constant tension. You gotta have enough clusters that they make sense, and then within you summarize them. I think that's what you do.
Ellen, did you have your hand up? Maybe we've lost her. Maybe she's on mute. Anyway, Sam, I saw you had a couple things in the chat.
This was just following along, I think, some of the discussion where I couldn't get a word in.
Right.
Yeah,
I think you made some excellent points along the sort of psychology perspective, but John here is bringing up some executive math constraints.
Yeah. So I'll make maybe one more point that's separate from what was going on in the chat, but that addresses, I think, a question you asked at the start of this session. I think it's a very, very good idea to get more people in this space taking courses, reading books on educational testing and on sort of psychometrics, psychological testing. So I think they're dealing with pretty clearly analogous problems, and there's a lot we can learn. I do want to say, though, I think it's not a silver bullet. I think we still have to solve these problems for ourselves, in that the way that our systems are going to cheat are very, very different from the way students are going to cheat. Students haven't memorized every book ever written, and yet are unable to figure out that apples are sometimes green. Like we just, yeah, things will go wrong in very different ways. And then, unlike in psychometric, sort of educational testing, though, has this nice analogy that sort of, like students, systems have an incentive to cheat and kind of can cheat in some ways. They can look at some more data. With psychometrics, cheating is much, maybe I think cheating is much more of a real concern, or gaming the metrics much more of a real concern here than it is with a lot of the what's going on there.
So maybe we better move on. I have a really hard time maintaining time. Eunsol, do you want to go now?
Sure. Can people see the slide?
Yes.
Okay. Cool. So I'm going to talk a little bit about context for interpreting benchmark performances. So when you put out benchmark, usually it consists of 3 parts. One is the data, input X, output Y, and then we have an evaluation metric that measures the similarity between output Y that's annotated and then the output Y that the model generated. And then we have a bunch of model that maps input X to output Y, right? So this is how we design benchmarks usually, and then we just score and rank the models based on this evaluation metric. The higher the model that gets out the highest score is the best one.
Well, we can see only a very small image of your slides. We're mostly just seeing your reminders window.
Oh, really? Okay. Let's see. How can I do a better sharing?
Can you make the slide window bigger? That's it. Excellent.
Okay.
Much better.
Okay, cool. Thanks, Sam. Yeah, so I think first part of my talk is talking a little bit about like how can you put provide context for different models. So even though we treat them as all same according to the single evaluation metric, which is usually the performances, models are different, and trying to make comparisons more fair by taking into consideration the computational resources that each of these models are using. In the second part of the talk, I talk a little bit about context for the benchmark data. So even though we say, you know, this data is for machine translation, or this data is for textual entailment and so forth, actually there are just further implicit assumptions that's baked into our data sets. So here's the example of question answering. So if we build a question answering data set where, like, you know, who is the vice president, and then the answer is labeled as Kamala Harris, then this data set is making this implicit assumption that it's asking about the United States, and it's asking about the present time of 2021. So like trying to, I think my talk is about, like, let's think about both of these contexts, context for the models, as well as context that's kind of baked into our data sets. Yeah, on the first part, I talk a little bit like, you know, there are tons of benchmark that's out there looking just into NLP. There are this kind of general benchmark, and there are specialized benchmark focusing on particular aspect of language understanding. Just the larger models are doing better. That's trained longer on larger amount of data. So these are kind of successful across all sorts of benchmark. So we were thinking, can we compare models under that's using similar amount of resources? So this was a NeurIPS competition that we hosted last year. It's a collaboration with a bunch of people, many from Google. And the idea is, like, under the fixed resource constraints, what would be the best model achieving highest accuracy on open retrieval question answering task? Here we define the resources as memory, which is further defined as the number of bytes required to store a Docker image that contains complete self-contained QA system. So it includes the codes, libraries, model parameters, as well as like a document that the model we're going to retrieve. And we have different tracks. And basically we see this interesting different architecture. Some architectures are using this memory budget to store documents. Some architecture are storing that memory budget to have a bigger, larger neural network. So it's kind of like people come up with different innovative technology when they're optimizing for this different perspective. So actually, if you read our report, you could see kind of what kind of models that people have made when they're optimizing for this objective. Yeah, in the second part of the talk, I talk about this implicit context that's baked into our data. And I think one of the nice things about NLP is that, like, you know, as time goes by, we keep building newer data set that reflects the language uses in the real world. So in 1989, we were making benchmark based on this Wall Street Journal at that time. 2011, people started making data set that's on Twitters. And now we are making this like meme detections and like a lot of data on Reddit and so forth. So we are kind of on this similar to this computer vision community where data sets are supposed to be a representation of the world. But each of these data sets are making different implicit assumptions about the world that it's trying to capture. So Twitter data sets are capturing the Twitter word and so forth. Yeah, another thing that's we are seeing in our community is before benchmark was relatively self-contained and looking more into linguistic knowledge. So one of the famous data set, the universal dependencies, are looking into this grammar annotations. But newer data sets are looking more and more into bringing word knowledge into the task definition. So this is one of the newer benchmark data set where people are masking out parts of the sentence, and the model has to predict what should go into that mask token. So it's kind of testing this common sense and factual world factor knowledge. So the answer for this particular thing should be Einstein. And this is actually making us really think carefully about this exterior linguistic context that our data set is assuming. Because for linguistic analysis, even though the data set was built 2014, the parse for this sentence in 2021 shouldn't change too much. So similar with sentiment analysis, positive sentence looked still positive when you're reading it 2021. But then when we start looking into this more knowledge-oriented benchmarking, then the same benchmark, say we built this Cristiano Ronaldo plays for something, the answer we annotated is Real Madrid, but then we are evaluating this in 2021 and he moved to a different team. So there is this notion of benchmark getting kind of stale. And it's kind of similar also for models as well, actually, because these large pre-trained models are using the text that's only up to a certain time point when they are trained on. So in the recent paper submission, we were looking into this exolinguistic dependence, particularly for question answering. So if the question is which COVID-19 vaccine have been authorized for adults in the United States, the answer to this question changes over time. Similarly, there are kind of geographical dependence as well. Which COVID vaccine have been authorized by our government? The answer to this question actually changes both based on geographical and temporal context that it's assuming. So we were studying this in recent work. And basically we see that because of this temporal dependence of the models, when you kind of go beyond what's assumed in the model, as well as the data, then the performance starts to drop. Similarly, if the model is asking about more popular geographical region, the model was doing better, but then it degrades pretty rapidly when it goes to rarer locations. And just thinking about how can we keep benchmark relevant for the future? And I think there are different ways to go about it, but I can't really think of perfect solution for this. And overall, I was talking about this. How can we build kind of playing field level for different models when we're comparing them? And how can we really consider this exolinguistic context that's baked into our data sets? Okay, I think that's it. Thank you.
Good. So are there any questions? Looks like the chat is usually, so do we have a question here? Or the questions I'm seeing in the chat, I think, are about the earlier discussion? Or am I misinterpreting that? Do we have a question for Eunsol?
I have a comment on this particular.
Please.
Yeah, on when you talk about the extra linguistic, context, sort of, just to understand that a little bit better, when my prior model for thinking about that is this notion that so much of that affects our interpretation of the language is not in the language, it's not in the content, it's not directly in the content. So we're drawing from a lot of information that's not there, maybe not even directly in the related corpus to make the inferences or to produce the interpretation from that content. And is that also what you mean by extra linguistics? How would you characterize that?
Yeah, so basically by reading that sentence, it's not in the text that we are reading. So it's like a metadata, when was the question posed? When was the document written?
Okay, so, but still stuff that you could, is directly related to that text versus things that are, in other words, common sense knowledge that we might draw upon in order to make inferences from what we read, in order to interpret what's in that text. Is that also included in how you're thinking about extra linguistic?
I kind of common sense is it's more like a background knowledge. So
okay.
it's not necessarily what.
Okay.
Yeah, that's more aesthetic in my mind. Although it's not really.
Yeah, so I'm kind of, this reminds me of this old theory called, I think it was called situated semantics. It was a book called Situations and Attitudes that got a lot of attention in the Stanford linguistics department in the 80s. But that's probably going deep into the philosophy, the idea being that meaning depends on context, and there's all kinds of contexts. So, that is in the real world, when a mother's talking to the kid, they're pointing at things and stuff's happening, and it's hard to understand what's going on without all that context. I keep gravitating from your examples about time to web search, and it's obvious the answer to a web query depends on time and space and many other variables. But another related question to web search is web crawling. So one of the things that a search engine has to do is to have in their cache some kind of accurate reflection of the web pages that might be the answer to the next question. And it's very difficult to keep the cache up to date. You can't afford to crawl all pages all the time. And so there's a kind of time latency importance trade-off. Some pages are changing at a sort of predictable rate. So the newspapers will update at the news cycle. There's other pages that update faster than that, and other pages that update slower than that. And so they can kind of estimate the interarrival rate of the chance of an update. But then another one is that there's some pages that are more important than others. So the consequence of having a stale page that nobody ever looks at is probably not so bad. But a stale page that lots of people are going to look at, or people would really be upset with showing them, day-old donuts, is a real problem. So I guess you have a slide here where you're talking about trying to estimate the latency of certain time. Here I'm talking about the latency of a web page, which is probably easier to define. But it seems like it's an empirical question. For every page, can you estimate how quickly it's likely to change?
Yeah, so we were just basing a lot on Wikipedia. So,
yeah.
And then we just ask human to annotate the most recent answer and then the previous answer. And for the data we collected, we are plotting this. So I think one way to do it is you could kind of train a classifier to tell which questions where you have to update more frequently versus which question looks like it's more stale. It's okay to stay there for a while. There are some questions where answer never changes, like who founded Google, right? The answer to that question never changes.
Yeah.
So
I think that the update to the questions is more complicated than the update to the answers. So if I said the answer is going to be a web page, say for web search, and then I can ask whether the web page changes. Now, even then it's difficult because some pages change every time you crawl them, right? They've got a page counter in it. The page counter will be different every time you visit it. But here I think you're getting at, this is a harder thing, which is how to know whether the answer should change. I'm not, that is, I can't annotate all pages all the time. So, you can estimate. And I think Wikipedia is probably an easier case than the general question. Because for Wikipedia, you do have change history and you could actually estimate how quickly people change the content.
Yeah, so actually one of my students is looking into those change histories, but a lot of changes are not factual, but it's more editorial.
Sure.
And people fight about connotations of saying this word about this person that's bias, so they are changing it to this. So it's not that easy to figure out what's the new context.
Well, and then there are these editorial wars. I once had a boss, Eric Brill, who was in a Wikipedia fight with another Eric Brill. And the two of them kept trying to take over the Eric Brill webpage to the point where they both got banned. Okay. But anyway, some edits are, I mean, I think this would give you a bounds on the estimate, but sure. Anyway, there's certain, I think people have had to worry about this problem from a commercial perspective. Now they've only dealt with perhaps the web crawling side of the problem, but actually the change time isn't enough, because it's also important to work out what are the consequences of being old. You can't afford to do everything you'd want to do. So if I have to make trade-offs, how do I do that? And my guess, Anyway, I think there are people who've seriously thought about some of these questions, and we should not only try to solve them, but we should try to figure out who else has thought about them. Because my guess is that this isn't, the semantics of time has sort of, been studied over thousands of years. There's great philosophers who've thought about it, but there's even practical engineering work rather recently, but it's not maybe in our community.
This is like, I mean, when you even think about just going back to basically understanding the simplest story, where is Rover? Rover's in, 5 different places in the story. And it sort of depends, like there's not a single answer to that question. It's sort of conditional on at what point in that timeline. To answer that question, you could make a simplifying assumption that's like, well, at the end of the story, where is Rover? But different events occurred, Rover moved, and he moved for different reasons. And this gets to like, what are the, we all expect people to understand that.
Yeah, so I think what's really frustrating is when the machines seem like what's called twice challenged, where these kids are super brilliant at math, but they can't handle simple English questions. And here you get a computer that, has memorized all of Wikipedia, can answer all your factoid questions, but they can't, do simple arithmetic, or they can't do simple inferences about time.
No, yeah, and that's when we talk about, the bit of work we did on this, that's what that record understanding basically plays out. That's why like one story turns into a big record of understanding that maps out every event and the effect every event has, and then you generate multiple choice questions from that to try to tease out whether or not, in fact, you understood the temporal, spatial, causal, motivational dimensions of the content.
One of the papers in the best paper session was kind of relevant. They were talking about outliers, and outliers meant, so they were trying to figure out like what was screwing up active instance learning. And I think what they came up with is that there were a bunch of questions for which the technology we've got in mind is quite reasonable. And then there's some others where they're just too hard. And some of the ones that were too hard are really easy for people. Like, there'd be something that would involve solving a CAPTCHA, like, what's the text in this image? And anybody can do it, but no machine.
I got news for you. I can't do CAPTCHAs anymore. They're so hard now, I can't even do them. So
all right, fine. All right. So, but anyway, there are lots. I think it's easy to build a task that would separate, people from machines. So some of these things that we're getting at are maybe getting into that area where, but some of the CAPTCHAs, it seemed really hard when they first came out of it. There was one which was have a machine distinguish the cats and the dogs, and oh, by the way, you can adopt all of them. So they show you a bunch of pictures of cats and dogs. They're all available for adoption, but the task is which a cat and what's a dog. And for a little while when they put this out, it was a good one for a CAPTCHA, but then the machine solved it. So if we put this one out as a CAPTCHA, I'll bet the machines would do pretty well. Anyway, are there any questions for Eunsol? Should we move on? All right, so why don't we go to the next speaker?
Okay, hello everybody. Let me present my screen.
Yes, hi.
So hi, and thanks for having me here again. And just a heads up that some of you might have heard this talk in session 1. If so, welcome back. So I'm going to change
Alëna, your screen is black.
That's interesting.
I think maybe you had to double click on it. It says double click to enter full screen mode.
Can you see it now? Because it shows that I'm sharing the screen. Yes? No?
No, I don't see it. We had this problem before.
Okay.
It might. Yeah.
I'm sorry. Might be an issue of having two screens at the same time.
Yeah, sometimes it helps, I think, to mirror your display so both screens are the same.
So can you see
there?
it now?
Now I see it. Yes.
Okay, fantastic. So, yeah, I'm going to change the topic a little bit and talk about the speech instead. So, what me and my colleagues from Google Speech worked on is how to create better benchmarks for speech recognition. So, the metric that you're probably familiar with is the word error rate. So basically, it's the percent of the mistranscribed words, and it's a standard ASR policy metric. And in fact, if you will look into recent benchmarks of ASR, we see word error rate reported as low as 1.4, and that's like really, really impressive. It's like nearly only one word mistranscribed out of 100. But if we will look instead on the real life ASR performance, it's not so good. You might have noticed it with your phones and other devices as well. So there is a big quality differences for different language varieties, for different domains like be it dictation or movie captioning. And even the speed of the system itself is very, very important. So chasing word error rate is pretty dangerous because as Goodhart-Slow points out, that when a measure becomes a target, it ceases to be a good measure. So in our talk, we want to outline and imagine steps towards better evaluation of ASR systems. And basically, there are three big parts that we are proposing. One is improving the types of data that we use to evaluate ASR models, namely increasing the amount of domains that are represented, such as dictation, conversation, podcasts, and so on, and introducing various challenging factors from real life, like complicated terminology, various speaking rates, noisy environments, and so on. So that's the first part. Then I will talk a little bit about metrics that we need to pay attention to. Of course, word error rate is important, and I will outline a couple of flavors of it, and also go beyond word error rate, like latency, real-time factors, and other timing-related parameters. And third part that's very important is how do we make sure that actually speech recognition systems work for everyone? So for different gender, ages, language varieties, regional language varieties, and so on. And I will outline a framework that might help us with the last task. So I will very quickly go through different ASR used scenarios and challenges. So basically, our task is just to cover as many real-life scenarios as possible. So we definitely want to cover dictation, for example. It's a bit different than spontaneous speech because it has some properties of speaking to a device, like you usually speak a bit slower with better articulation and so on, and even some subtypes of the dictation, like medical dictation, that of course has this challenge of having complicated and constantly changing terminology, and dictation practice that usually language learners are using. And in this case, the challenge is actually providing some pronunciation feedback. Then there are some other types of communicating with technology, like interactive voice response systems. So sometimes when you call tech support, it will be the robot that will be talking to you first before the human takes over. Voice search and control, like putting a timer or accessing some information, and so on. So these types that I covered so far are basically humans talking to technology. But then we also really need to make sure that we have represented humans talking to humans, such as meeting, podcasts, movies, and beyond. In this case, the speech is spontaneous, so there are plenty of disfluences. So we can hear something like, they gave me this, how do you call it? And then like corrections and speech like this that is much harder to transcribe. Yeah, of course, the speaking rate is much faster in this case. And then apart from that, it would be also very good to have benchmarked assets with introduced technical challenges, such as terminology and phrases, like medical terminology, historical phrases, and neologisms, varied speaking raises, noisy acoustic environments, background noises of all the different types, and even encoding formats, because they might be challenging as well. So that was a very, very quick overview of different domains and challenges that we are proposing to have represented in the ideal ASR benchmark sets. And now let me switch to the metrics. So just to repeat that word error rate is the most important metric and for ASR quality. It's just, yeah, it is a percentage of words that are mistranscribed, but let's imagine two real-life scenarios. So we have two systems. We're comparing two systems. Their word error rates are pretty close, but their latency, so like how fast the system works, are quite different. And even though it's tempting to say that the system with a lower word error rate is better than the system with a higher word error rate, in fact, in real life, we will probably choose the system with slightly higher word error rate, so the one that does more mistakes, but lower latency. Because like this, there will be like no frustration waiting for your query to be transcribed. But also there are different flavors of word error rate that we might be looking into. So just a heads up that word error rate treats every word equally, and it's a small problem in its own, right? Because different words have different amount of information in them. Like transcribing a word like hurricane might be more important in certain settings than transcribing the word like there. Also we cannot be comparing word error rates across different languages because a word is a language dependent concept. So the word error rate for Russian will not mean the same thing as the word error rate for let's say Cantonese, because the word is a very different thing in those languages. So yeah, just a small note that written domain conventions also influence word error rate. So it's basically agreements of how we transcribe words. Do we when we hear kinda, do we transcribe it as kinda, or do we standardize it to kind of? If it's dead mouse, do we mean idiom artist, or do we mean dead mouse? And like some things like this. And also, we can even take word error rate and calculate it individually for different classes and domain terminology. So maybe we want to know word error rate on stop words. Maybe we want to know word error rate for numbers, for names, and so on. Because it is important to look into word error rate deeper, because average word error rate is not enough to show the distribution of misrecognitions. It's more like very, very generic metric. And beyond word error rate, it's also good to look into metadata about words. I will skip it very fast, but basically it's good to know per word confidence scores. So how sure we are that that word was transcribed correctly. And also it's useful, it would be useful downstream to have phonemic transcription, right? Because sometimes orthographically words are the same, but they are pronounced in a different way, like Houston, that's Texan City, or Houston, that's a street in New York. And lastly, I wanted to highlight that another like set of metrics that's very important is latency and timing related metrics. So latency is the average delay between every spoken word and when the transcript was written. Real-time factor is more like a generic thing, like how long did it take us in general to process that audio. And if we're concerned with streaming ASR systems, so something like that transcribes on fly, we also want to have metrics that describe how reliable our intermediate guesses are, or like how frequently the model changes its guesses about the transcriptions. There are other important metrics that I'm not going to cover in depth, like training related metrics, how much data do we need to train it, how big does the model get when we train it. Hallucinations, how often does the model hallucinates hearing words when they're not present, in fact, and also debuggability. So like how easy it is to introduce new words such as COVID-19 in the model, right? So how easy it is to fix the issues. So far I quickly outlined different domains and the challenges that are good to have represented in the test sets, and also which metrics it would be good to pay attention to. Another thing is language variation. So language variation can take very different kinds, right? There is phonetic differences, lexical differences, voice quality differences, and so on. So our idea is that we need to be slicing every metric for different different categories of speakers. So I will explain in just two slides what categories of speakers we are proposing. But the idea is that the ideal test set must be representative of the target user base. So of course, it's very challenging to get test sets with very rich metadata. But in this case, we need to take the sets and reweigh the amount of utterances with respect to the sizes of population groups. So take a look at the bottom side of the slide. So the idea is basically if the amount of utterances of the type A is disproportionately more than the size of the group A itself, the weight of the quality metrics on the utterances need to be decreased a little bit, right? So if we will just calculate overall word error rate for the set on the left side, it will be not exactly representative of the population. So yeah, we are proposing to reweigh the metrics a little bit. And let me give you actually like a little hands-on example of such population-weighted framework application. Let's say that we have three mutually exclusive groups. One is 60%, another one is 30%, and another one is 10%. So I have two model evaluations on the right side, right? So width of the bars represent the size of the group and height represents the word error rate. So the overall word error rate is exactly the same for these two pictures. So if we are just looking at the word error rate itself, it's 10. But if we will start comparing the gaps between the best performing and the worst performing classes, of course, we will see that on the first plot, the gap is 12.8. That's terrible. And on the second one, it's 3.5. That's much more decent. And of course, the models that are preferred are more consistent. So different people are getting more consistent quality transcriptions. So I mentioned that this works for mutually exclusive groups. And of course, you might mention that, but it never happens like this, right? Let's imagine the scenario where we have a 25-year-old female speaker of Chicano English from Miami. So what is happening here? We have age, we have gender, we have social act, we have regional variety, and so on. Of course, everybody falls in several groups at the same time, but it's very, very challenging to get sets where every intersectional group is represented. So that's why we would like to propose sticking with the mutually exclusive groups, so we can evaluate every parameter independently. And this will help us to make new insights without making more assumptions about like how this underlying latent variables actually interact. So just to start the list, it's not exclusive, of course, but just to start the list, what important slices are there? Definitely regional language variation, definitely social acts, such as Chicano English, Galician Spanish, African American English, and so on, L2 backgrounds, or non-native speech. So depending on like if you are a speaker of Russian or German, your English speech will be a bit different. Gender, age, and pitch. And in fact, since pitch correlates with gender and age, it also can be helpful for us to look into pitch buckets. And also speech impairments. So how various speech impairments are affecting the quality of the speech recognition. So just to conclude, three main areas: more domains and challenges into the ASR test sets, wide range of quality metrics, and using population-weighted approach to ensure that the speech recognition systems are actually performing well for everybody. So that produces a lot of different numbers. And what we can do is to follow Mitchell et al. 2019 and organize and present data like this as system report cards. So by no means what I just presented is exclusive. It's not enough. But even adopting some of these proposed methods will already be helpful to do better ASR model evaluation. However, it's not exhaustive. And actually, that's exactly why we wanted to start this conversation, that we started today in the session 1, because Valia Cardoni, for example, already pointed out that, oh, but in these slides in particular, we didn't cover multilingualism yet, and that is a very important parameter, of course. And Anders Sogard, I'm sorry if I'm mispronouncing the name, also pointed out that actually domains of ASR applications change as well, and this is also something that we need to be preparing for tomorrow and reflecting it in our test sets as well. So yeah, this is exactly why we wanted to do this work, to invite more and more insights into how to make ASR applications, ASR evaluations better. Thank you.
Well, that's great. So are there any questions? I'm not seeing much in the channel. Anybody? Oh, no, I see somebody clapping their hands. That's Valia. It's not a request to ask a question.
Thank you.
Is it? No. Oh, did I see? Yes, John.
I was just a little amused. They're good material. At the British English versus American English. My wife is British, and she normally speaks Cambridge, London English, but she originally is from Yorkshire. And they may resembles English. I would say when it comes to local dialects, the UK really goes all out on English, because they've got a lot of different ones. I mean, when I go into a grocery store in Yorkshire, I just don't really understand what they're saying. So
Actually,
you might want to take a look at that. It's not a simple three-way split.
Exactly. And if it's a problem for humans, of course, it's something that we need to be very careful when facing ASR systems.
So when Siri first came out, there was a wonderful review on YouTube by a young woman who was from Yorkshire, and she was trying to show to her quite large audience all the things you could do with Siri. And but she was actually very good with language. And so she asked Siri a question, and it didn't work. So she then said, "Oh, it's got to be my Yorkshire accent." And then she came out with a wonderful imitation of an American accent, and it just worked. At any rate, I'm sure that they're much better now. I see another hand up there. John? Yeah. You're on mute?
Yeah. So in keeping of the, thank you for the talk. I think in keeping with the theme that we've heard from several of the other speakers, I'm wondering if some things where ASR might contribute to downstream tasks would be of interest. So for example, I think there's work that prosodic segmentation then can contribute to parsing, and perhaps a contrastive stress recognition, again, prosody, can contribute to some aspects of maybe a knowledge graph. So is this something that is on the roadmap, or is this kind of taking people too far out of their comfort zone?
This is something that's actually really important to be looking into, because there are, as you said, yeah, there are many downstream applications of ASR. And you already mentioned that if we're paying attention to the decays and clauses, it might potentially help with parsing, or if we have more metadata about words, and it might help with the translation better, right? So I gave already the example of the Houston, Houston. So in this case, like having this differences and phonemic annotation will help us to have downstream application of navigation better, but then also more like facing machine translation, for example. Apart from that, there is also live and live that are adjective and verb, depending on how you say them. And I'm sure that it might be helpful for MT applications as well to know all these distinctions. So yeah, exactly. This is very important to keep in mind, because having better evals and having better setup for ASR systems can actually bring more value beyond ASR systems as well.
Thank you.
Thank you for pointing it out.
Yeah. All right. Well, any more questions? All right. So the next session is, let's see, I think it's in 4 hours from now. So I won't say what time it is because well, we had this discussion about how all these semantics are situated. Okay. Anyway, this is a really wonderful talk and it's getting a lot of views on YouTube, and I would encourage you to go add to the views. It's you know, it's just right on, all kinds of details that we have to think about, and so on. Now, for the executive math that we have to do, it's not helpful, right? That is, we need a really nice, simple solution, like a single number. How are we doing? And nice word error rate. I like that 1.4%. Although probably that's too high an error rate. You can't afford that. Yeah. So anyway, I'll see everybody then. Well, maybe I'll see some of you in a few hours. I tried to set up these Zoom calls so they would go around the clock. We get one day anywhere on the world to have our calls. And I wanted to do it in a way that would not disadvantage people in Asia or Europe or anywhere else. I didn't quite get it right, but we tried pretty hard. And of course, the stuff on YouTube will be available anytime. And I have no intention to take it down ever. Let's enjoy this. Some people are suggesting that maybe we should come up with a way to continue this discussion into the future somehow. I'm not sure exactly how, but if you have any ideas, please let me know. So see some of you in a few hours, and thanks for coming. And thanks to speakers one more time.
Thank you so much for organizing this.
Yes. All right, take care.
Thanks, bye.